Welcome back to the deep dive. Today, we are standing in front of a fortress. For decades, if you worked in core banking, specifically with the massive T24 system, you were basically faced with a binary choice.
hmm
You were either inside the fortress, part of the priesthood that spoke the secret language, or you were outside, just staring at a black box.
That is a surprisingly accurate visual. And for a long, long time, that secret language was JBC, or what the veterans just call Info Basic.
Right, and if you didn't know Info Basic, which is a dialect of Basic, by the way, you weren't touching the core. You couldn't customize it.
Not all.
But the research we have today describes this massive renovation project. We are looking at a set of keys that effectively opens the gates of that fortress to a much, much larger world.
Yeah, we're talking about the shift to Java extensibility within T24.
Exactly.
And it's a fundamental shift. It's
Yeah.
important to state up front. This isn't just about swapping one syntax for another. This isn't just, oh, Java's popular, so let's use that. This is about the survival, the scalability, and really the modernization of banking architecture.
Yeah.
We are moving from a proprietary niche environment to an open industry standard ecosystem.
So the mission for this deep dive is kind of twofold. First, for the architects listening, we need to understand the why, the strategy behind this move.
Right.
But then, and I think this is where we're going to have the most fun, we are going to get our hands dirty. We are going to walk through exactly how a developer builds a hook in Java to control a live banking
And
transaction.
we're going to verbally code it, we're going to deploy it, and we're even going to talk about how to debug it on a live server.
Okay, so let's start with that strategy, because usually in the banking world, the golden rule is if it ain't broke, don't fix it. T24 has run on JBC for a very long time. It works. Why the sudden push to Java?
The source material really boils it down to two main drivers: talent and governance. Think about the labor market. If you are a CIO at a major bank and you need to hire 20 developers tomorrow to build a new loan validation module, and you need them to be experts in JBC, well, good luck.
You're hunting for unicorns.
Exactly.
Yeah.
It's a shrinking pool. But if you need 20 competent Java developers, you can find them in every city in the world. The documentation highlights that this shift allows banks to democratize their development,
Right, so they can use their own in-house teams.
their own teams.
Uh-huh.
People who are already building their web apps and mobile front ends, they can now actually extend the core banking software.
That makes perfect sense for hiring. But you mentioned governance. That sounds a bit more restrictive. How does Java help with governance?
It helps by creating a safety net. In the old world, the JBC environment was incredibly powerful, but it was also dangerous.
How so?
If you weren't careful, a developer could write a routine that performs a select on the entire transaction history table.
The database equivalent of trying to drink from a fire hose.
It's worse. You're drinking from the fire hose while standing on the hose, effectively cutting off water for everyone else. You could literally freeze the system.
Wow.
The Java extensibility framework, it acts as a protective layer. It forces you to use specific APIs to access data. You can't just run wild SQL queries.
So it prevents you from shooting yourself in the foot.
Or at least it makes it much, much harder to do so. It also abstracts away the physical layer. A Java developer doesn't need to know how T24 physically stores an amount field on the hard drive. Is it flat file, an Oracle, BLO, who knows?
They just use the API.
They just use the API, and the system handles the translation.
That is a perfect transition to the toolbox. If I'm that Java developer and I sit down at my IDE, I'm not just seeing standard Java classes. The documentation talks about these things called T-types.
The T-types, you cannot escape them. These are the proprietary wrapper classes T-Minos created to bridge the gap between the T24 core and the Java world.
Okay, let's break the big ones down. The documentation keeps mentioning T-structure. What exactly is that?
Key structure is your generic container. To understand it, you have to look back at the legacy system. In T24, a record, say, a customer's profile, was basically a dynamic array.
Right.
Imagine a really long string of text separated by little markers. T-structure is the Java object wrapper for that data.
Okay, so it's the box that holds the data.
It's the box, but it's a generic box. And this is a crucial concept for anyone listening who is about to code this. When you get a T-structure, Java doesn't know if it holds a customer, a loan, or a money transfer.
So you have to tell it.
You have to cast it. You have to explicitly tell the code, treat this T-structure as a funds transfer object.
Got it. So step one is labeling the box. Once I'm inside that box, I assume I'm dealing with the actual data fields.
Yes, and that brings us to the workhorse of the entire system, T field.
Now, this is where I got a bit stuck in the notes. Why do we need a special class for a field? Why not just use a standard Java string or an integer? If the customer's name is John, why is that a T field?
Because in banking, a field is never just a value. A T-field object holds the value, yes, it holds the string, John, but it also holds all this metadata. It has methods for enrichment, like describing what a specific code means, and most importantly, it has methods to set errors.
Ah, so if I want to tell the user invalid name, I don't throw a generic Java exception.
No, and please don't do that. That will just crash the process. You call a method specifically on that T-field object. You say myfield.setter invalid name.
So the error is bound to that specific field on the user's screen.
Exactly. That way the field specifically lights up red, rather than just a generic error message at the top of the screen. A standard string can't do that.
That creates a much better UI experience.
Much better. And they have mapped the whole ecosystem. You have T-string, ToNumber, T-date. It's a mirror of the banking types just inside Java.
There is one more type in the source material that we need to clear up because it seems to be a major point of confusion for people moving from building apps outside the bank to building apps inside the bank. And that's T24 context.
Yes. This is the connection string object. If you are building a standalone Java app on your laptop that needs to query the bank to get a balance, you need a T24 context to log in, establish credentials, and create a session.
But here is the twist. Today, we are talking about building a hook. We are building code that lives inside the transaction.
Precisely. And the documentation is bold, underscored, and highlighted on this point.
Yeah.
Hook routines do not need a T24 context.
Why not?
Think about the direction of the traffic. In a standalone app, you are calling the bank. You need to knock on the door. In a hook, the bank is calling you.
You're already inside.
You are already inside the fortress. The context is implied.
Yeah.
If you try to create a new context inside a hook, you're essentially trying to log into a system you're already logged into. It's redundant, it wastes resources, and it can cause errors.
That is a crucial distinction. Don't knock if you're already in the living room.
Exactly.
So let's talk about being in the living room. We're talking about hooks. How is a hook different from an API?
The simplest way to view it. APIs are code Temenos wrote that you call to get information.
Okay.
Hooks are code you write, which T24 calls it specific moments to ask, hey, is this okay? Or do you want to change anything?
And those moments aren't random. The documentation lays out this really structured timeline called the version lifecycle. I love this because it visualizes the flow of a transaction. It's not just user hit save.
No, it's a gauntlet. A transaction has to survive a series of checks, these exit points, to make it to the database.
Let's walk the listener through this gauntlet. So I'm a bank teller. I open a funds transfer screen. What is the very first thing that happens?
Before you even see the screen, the system triggers the .id routine. This validates the ID you're trying to open. Is it a valid account format? Does it even exist? Then immediately after, you have the record hook.
What's the point of record? The user hasn't typed anything yet.
This is your chance to set the stage. It's commonly used for default values. So if you want the currency field to automatically populate with USD or the date to be today's date, you put that logic in the record. It pre-fills the form.
Okay, so the screen loads, I type in an amount, I type in a beneficiary.
And every time you tab out of a field, the .validate hook fires. This is for checking that specific field in isolation. Is the date valid? Is the amount positive? That kind of thing.
And then the big moment. I hit commit.
Then you hit process. This is the heavy lifter. This is for cross-record validation, checking limits, doing the complex math. If you survive .process, you go to authorize, which handles the final writing to the database.
It really is a gauntlet.
And that's the power. You can inject Java code at any one of those stops to alter the destiny of that transaction.
Okay, enough theory. Let's build something. We're going to take a scenario straight from the source notes. We need to build a validation for funds transfer.
A classic requirement.
Here's the rule. We want to ensure that the credit currency matches the debit currency. Basically, no foreign exchange allowed on this specific version of the screen. If I send dollars, I must receive dollars.
Simple, logical, but it requires looking at two different fields at the same time.
So, step one. We open our IDE Eclipse, or Design Studio as it's called here. We create a new Java class. What are we typing?
Well, you're not starting from a blank page. You need to extend a specific superclass called Record Lifecycle.
Record Lifecycle. The name implies it covers that whole gauntlet we just talked about.
Exactly. By extending Record Lifecycle, your class inherits empty versions of all those exit points. Record, validate, process. You just need to override the one you want to use.
For this scenario comparing credit versus debit, which one are we overriding?
You want to override validate record
Now, play devil's advocate for me. Why that one? Why not validate field?
because validate field has tunnel vision. It only knows about the one field you just touched. If you're in the debit currency field, you can't easily see what's in the credit currency field because, the user might not have typed it yet.
Or they typed it first.
Right. Validate record triggers when the user tries to commit the whole deal. It sees the full picture, the complete state of the record.
Okay, that makes perfect sense. So we are inside the validate record method. We have our T structure, which represents the current transaction. How do we get the actual data out?
First, you cast that structure to a funds transfer object. Now you have access to the specific getters. It'll look something like current record.get debit currency to grab the first T field.
Right.
And current record.get credit currency to grab the second.
Now I have two T field objects. I can't just compare the objects themselves.
Correct. You need to pull the values out. So string debit, debit field.get value, and string credit, credit T field.get value.
And then?
Then it's just pure vanilla Java. If debit.equals credit, it's the same logic you'd write in any Java 101 class.
And here is the kicker. If they don't match, we need to stop the train. How do we tell T24 to stop?
You take that debit field object, the actual object we retrieved earlier, and you call cterror. Currencies must match.
And that's it.
That's the logic. By setting that error, T24 knows the validation failed. It will abort the commit and show the error right on the screen to the user.
The code sounds simple enough, and this is the part that usually trips up developers new to this ecosystem. Saving the Java file on your laptop doesn't stop a transaction in the bank. We need to deploy this thing.
This is where the infrastructure comes in. You can't just copy-paste the code. It's a strict process. First, you export your code as a JAR file at Java archive. That's your package.
And where does that package go?
It goes physically onto the server running the T24 application, specifically into the JBoss module folder. But here's the friction point that every developer needs to know. You usually have to restart the JBoss server.
Restart the server in a bank. That sounds disruptive.
It is. In a production environment, you have to schedule this during a maintenance window. The server needs that restart to load the new JR into its class path. It won't pick it up on the fly.
Okay, so let's say we've done the restart. The server's back up. The JR is loaded. Is my validation active?
Not yet. The code is sitting there loaded in memory, but T24 has no idea it's supposed to use it.
Right.
We have to bridge the gap between the Java world and the T24 dictionary. We do that with an application called eb.api.
eb.api. This feels like the phone book for the system.
That's a great analogy.
Yeah.
You create a record in eb.api. You give it a logical name, say check.currency.match. You set the source type to method. Then in the details, you specify your Java class name and the package name where your code lives.
So this record tells T24, hey, if anyone asks for check.currency.match, here is the address of the Java class that handles it.
Exactly. And the final link in the chain. You go to the actual setup for the funds transfer screen, the version application. There is a field called input routine or validation routine. You simply type check.currency.match in that field.
And that's the moment it goes live.
That's the moment. Now, when a teller hits commit, T24 pauses, looks up the API record, finds your class in JBoss, runs your logic, sees the mismatch, and blocks the deal.
It's a journey from logic to JR to JBoss to eb.api to version. It's not a one-click deploy.
No, but it's a robust pipeline. It separates the code from the configuration. You can change the screen setup without recompiling the code and vice versa.
Now, in the real world, code rarely works perfectly the first time. I might have a typo or I might be checking the wrong field. The source material spends some time on Design Studio and specifically debugging. This used to be a nightmare in the old system, right?
In the old system, debugging often meant adding print statements to your code, running the transaction, and then digging through text logs after the fact. It was forensic analysis, not real-time debugging.
And with this Java shift,
We get modern tooling. Design Studio is based on Eclipse. You can double-click the margin of your code, set a red dot a breakpoint, and execution will freeze right there. You can inspect variables, step over lines.
But wait, my code is running on a JBoss server, maybe in a data center somewhere. My Design Studio is on my laptop. How does my laptop freeze the server?
Remote debugging. This is the expert trick in the notes. You have to configure the JBoss server with a specific flag in its Java OPTS. It looks like netgear and jdwp.transport.dt socket, and usually listens on port 8787.
Port 8787. Memorize that, folks.
What this does is it opens a side door on the server. Your design studio connects to that port. When the server hits your hook, it sends a signal to your laptop and boom, your screen freezes at the breakpoint.
So I can sit at my desk, perform a transaction, and watch the variables change line by line inside the server logic.
You are watching the brain of the transaction think in real time. It completely changes the development cycle.
Yeah.
You aren't guessing, you're seeing.
That is incredibly powerful. It changes the game from guessing what happened to seeing what is happening. It really does feel like we are bringing banking software development out of the dark ages and into modern engineering.
It does. It aligns the specialized world of banking with the broader world of software development.
So we've covered the why, scalability, talent, and governance. We've covered the T types, T structure, and T field. We've walked through the how, the life cycle, the wiring via EV API, and the debugging.
It's a comprehensive toolkit.
As we wrap up this deep dive, I keep thinking back to that fortress idea. We've handed out the keys. But does that make the fortress less secure?
That's the provocative question, isn't it? The source mentions that developers can now protect T24 using this framework because of the governance layers. But the inverse is also true.
Right.
When you give standard Java developers access to the core transaction pipeline, the responsibility is immense.
You aren't just writing a script for a website. You are intervening in the financial ledger.
Exactly. A Java developer might know how to write a loop perfectly, but if they don't understand the business implication, like why a debit currency must match a credit currency in this specific version, or why a certain validation must happen at process and not validate, they can do real damage.
They can bypass checks that should be there.
Absolutely. So the barrier to entry is lower. You don't need to learn a dead language, but the requirement for business knowledge is actually higher.
The tool is better, but the craftsmanship is still required. You need to respect the transaction.
You really do.
Well, there you have it. From JBC to Java, we've walked through the modernization of T24 Extensibility. If you are a developer making this switch, dive into those Java docs, get friendly with T-Field, and maybe double-check your code before you restart that JBoss server.
Please do.
Thanks for listening to this deep